Welcome to new session. Today's concept is relation between radius of curvature and focal length and mirror formula. This concept we will see in this session. Before that, what we have discussed in the last class, sine conventions and basic terms in optics. Just I will remind what are sine convention and what is assumption in optics. We know that first sine convention was all distance are measured from pole. Second sine convention, along the direction of incident ray all distance are taken to be positive, opposite to direction of incident ray all distance are taken to be negative. And third sine convention, the distance measured upward perpendicular to principal axis taken to be positive, on the other hand the downward distance measured perpendicular to principal axis taken to be negative. One thing. Second one is some sine conventions, assumptions in optics. What are assumptions? The ray of light which is passes through principal axis, the ray of light is never deviated. Second sine convention, whatever angle of incident, whatever angle of refraction, so those are assumed to be very, very small. These are assumptions. And before that, we define two terms. One is the radius of curvature and second one is focal length. Radius of curvature is the distance between pole to center of curvature is called as radius of curvature. On other hand, distance between pole and principal focus is called as focal length. Now, let us start today's concept. Relation between radius of curvature and focal length. Relation between R and F. We know that concave mirror and convex mirror. But taking concave mirror or convex mirror, you can prove what is relation exists between radius of curvature and focal length. So, for my convenience, I would like to take a concave mirror. By taking concave mirror, what is the relation between radius of curvature and focal length? That we'll see. See here. To understand this relation, to derive this relation, let us take a concave mirror. See here. Shall I take concave mirror? I would like to take, this is one concave mirror. Right. So, one part is silvered. Concave mirror mean the mirror in which silvered surface is bulging and reflecting surface is diffract one. This second called concave mirror. Right. A straight line passing through pole, that we are calling principal axis. Remember this. Look at me. I can take this is nothing but straight line that is passes through pole. I can call this is principal axis. In simple way, I can call this is nothing but principal axis. Simply this point I can call pole. Center part of the mirror, that we are calling pole. Look at me, this center part of the mirror. Now let us take a ray of light incident on the mirror and get reflected. How this is? See here. Let us take this nothing but ray of light which is parallel to principal axis, incident at this point. Let us take the ray of light incident at M point. After incident, this ray of light is reflected like this. Are you following? How it is? The ray of light incident at M point and it reflected back. Let us consider the ray of light passing through principal axis, so meet at this point I can call focus. Focus means after reflection where the ray of light is meet on principal axis, that point we are calling focus. Now, where the ray of light incident, at this point ray of light is incident. We know normal. Perpendicular line drawn at point of incident we are calling normal. How to draw the normal for it? See here. If I draw, let us take, this is nothing but perpendicular line which is drawn at the point of incident. This I can call normal. Let us take the normal is drawn from point C, where C we are calling radius of curvature. C we are calling radius of curvature. We know two angle, one is angle of incident and angle of reflection. See here, what it is? Angle between incident and normal, this we are calling angle of incident represented by theta. Are you following me? Similarly, this second called reflected ray, angle between normal and reflected ray, this we are calling what? Angle of reflection, again represented by theta. Right. According to geometry, what we know? According to geometry, if this is theta, this also theta. This also theta. See here, for spherical geometry, for linear geometry, what I will take? Simply I will draw a line. See here, simply draw Mn perpendicular to principal axis. Look at me. This is perpendicular line. This is what it is. Mn perpendicular to principal axis. Are you following this? We know two terms. One is the radius of curvature. Second one is focal length. What is radius of curvature? The distance between pole and center of curvature is called as radius of curvature. Shall I take? This second called radius of curvature, represented by capital R. Distance between pole and principal focus, what you can call, this is focal length. Right around this. Now come to geometry. According to geometry, this angle and this angle are interior angle. Interior angle, sum of interior angle must be equal to what value? Exterior angle. Sum of interior angle must be equal to exterior angle. Remember this. Then let us take here according to Sine convention. Along the direction of incident ray, all distance are taken to be positive. Opposite to direction of incident ray, all distance are taken to be negative. See here how the ray of light is coming. Ray of light is coming like this. Look at me. This is nothing but ray of light. Right? Ray of light is coming like this. Like this ray of light is coming. Opposite to direction of incident ray, all distance are taken to be negative. I mean, from geometry, what you can choose? From the geometry, the distance PC is equal to radius of curvature, and radius of curvature taken to be negative. Radius of curvature taken to be negative. Right? Because according to Sine convention, the distance between pole and principal focus, what you are calling? Focal length. What is focal length? Focal length PF. PF is equal to again what value? I can take F value. Look at in the geometry. In the geometry, the P point is very closer to N point. We assume that P point is very closer to N point. P is very closer to N. So that what will take? P point must be equal to N point. Right? Now we know relation between focal length and radius of curvature. I need relation between focal length and radius of curvature. Look at me. In the figure, two triangles are there. What are triangles? Triangle here MCP looks like one triangle. Which one is triangle? Look at me. Which is triangle? MCN looks like one triangle, and MFN looks like another triangle. See here. Shall I take triangle? Which is the triangle? Triangle. Which one? Triangle MCN looks like one triangle. MCN looks like one triangle. Right around this. Then from this triangle I will take tan theta. Tan theta mean what value? Opposite divided by hypotenuse. From this shall I take tan theta now? What is tan theta? Tan theta is equal to Mn. Tan theta is equal to Mn. Mn divided by Cn. Mn divided by Cn. Right around this. But according to assumption, theta is assumed to be very smaller. Whatever angle of incident, whatever angle of refraction, those are assumed to be very small according to assumption. So that if theta is very smaller, tan theta nearly equal to theta. See here, if theta is very smaller, tan theta nearly equal to theta. Theta is equal to how much? It is Mn divided by how much? Cn. I can call this is the equation number 1. Right. Now one more triangle is there. Which is triangle? MFN looks like another triangle. How it is? See here, triangle. How much? MFN looks like one triangle, another triangle. In this triangle, again I will take tan theta. Tan theta mean again how to write? See here, tan not theta. Here tan 2 theta available. Tan 2 theta is equal to how much? Opposite divided by adjacent. Opposite mean how much? Opposite is equal to Mn. What is adjacent? That is equal to NF. Again according to assumption, theta is very smaller. Tan theta nearly equal to theta. So theta is very smaller. Tan 2 theta equal to nearly 2 theta equal to how much? Mn divided by how much? NF. Are you following? Right thing? Then let us call this is equation number 2. Compare equation 1 and equation 2. Or I can write one more step. In one more step, shall I write 2 theta is equal to mn divided by nf, or what is theta? Theta is equal to what value? Mn divided by 2 nf, right? We can call it equation 2. Now compare equation 1 and equation 2. If we compare equation 1 and equation 2, what will get? Look at me here. What will get? See here. This also theta, this also theta. Compare equation 1 and 2. Mn divided by how much? Cn is equal to how much? Mn divided by how much? 2nf. 2nf. Right or wrong? This m and mn get cancelled. 1 by Cn is equal to 1 by 2nf, or else nc is equal to what value? 2nf. Are you following this? But in the diagram, the P point is very closer to N point. So that P is equal to N. Wherever N, we should take P value. Look at me. Wherever N, I should take P value. That PC is equal to how much? 2. N can be replaced by what value? PF. Right. But according to Sine convention, what is PC? PC is radius of curvature. I taken as minus R. PC is equal to how much? That is minus R. 2 keep it up, say. PF is equal to focal length. So again I can take this value is equal to minus F, minus get cancelled. What is remaining then? R is equal to 2F, or F is equal to how much? F is equal to R by 2. F is equal to R by 2. This is what? Relation between radius of curvature and focal length. Not only for concave mirror, this relation can obey for also convex mirror. Either you can derive for concave mirror or you can derive for convex mirror. For our syllabus, we need the relation only for the concave mirror. For convex mirror, no need to derive. Simply, what we got from this? Focal length is equal to radius of curvature divided by 2. I mean half of the radius of curvature, that becomes focal length. See here. Half of the radius of curvature, that becomes focal length. F is equal to how much? R by 2. If this is F, then what about this value? This value total PC is equal to R. So this is what? Relation between radius of curvature and focal length. Now after this, let us derive what is relation between object distance, image distance and focal length. Directly mirror formula. Mirror formula for concave mirror and convex mirror. That relation we'll see. See here. Shall I remove it? Our next concept is mirror formula. Okay. Shall we move? Next concept is mirror formula. Mirror formula. See here. In previous class we defined two terms. One is object distance, second one is image distance. Shall I define two terms? The distance between pole and object is called as object distance. Distance between pole and image is called as image distance. This mirror formula or relation between object distance, image distance and focal length, that relation we are calling mirror formula. This mirror formula either you can derive for concave mirror or convex mirror. Wherever light ray incident, after incident the ray of light reflected back, after reflection all the ray of light meeting at a particular point, that point we are calling image of the object, given object. This image either it is real or virtual. I define real and virtual image. If the image produced in front of the mirror, that we are calling real image. If the image appeared at the back side of the mirror, that we are calling virtual image. I mean, if the image appeared behind the mirror, that we are calling virtual image. Using concave mirror, either you can obtain virtual image or you can obtain real image. How we can obtain a virtual and real image, that we'll see. Before that, Let us take what is mean by concave, what is mean by mirror formula. Again, to derive the mirror formula, again I will take concave mirror. Look at me. Shall I take concave mirror again? I would like to take, this is concave mirror. This is concave mirror, right? Look at this one, I can call concave mirror. So one part is silvered, this part is silvered, right? Straight line passing through pole, that we are calling principal axis. Look at me. I can take, this is nothing but a principal axis, straight line passing through pole. I can call center part of the mirror, I can call this is pole, right? Now first case we will see when a real image appeared, when virtual images appeared. See here, let us consider object is placed behind principal focus and behind radius of curvature. Shall I take here? Consider this is one object. Let us take, it is one object. Say this object, shall I take? This object is equal to AB. AB is nothing but object just placed in front of the mirror. Now I am going to derive when real image appeared, when virtual images appeared. Let us take when real images appeared. Shall I take here? Real image means simply wherever image appeared in front of the mirror, that we are calling real image. See here. We know that this is nothing but one object, right? From an object, let us take a parallel ray of light incident on the mirror and get reflected back. How this is? Look at me. I can take this nothing but one parallel ray of light incident at some point. Let us consider the ray of light incident at M point. Right. After incident, this ray of light must be reflected back like this way. How it is reflected? In this manner ray of light is reflected back. After reflection, the ray of light passing through principal focus. So this point, what I can call, this point I can call focus. Are you following me? Let us take one more ray of light that is passing through center of curvature. How it is? Let us take here. Shall I take one more ray of light? This is one more ray of light. This ray of light passing through center of curvature and incident at this point. Incident at this point. After incident, this ray of light retraces its path. See here. Shall I take? Look at me once again. I will take this ray of light. Look at me. This ray of light, actually it is passing through center of curvature. Passing through center of curvature. Look at me. After passing through center of curvature, look at me. This is center of curvature. Right around this. Shall I take here? Look at me once again. I will take. Let us take this parallel ray of light reflected. How it goes? It goes like this. Right? Like this. So I can call this nothing but focus point. Right around. After incident, this ray of light passing through center of curvature, incident at this point and retraces its path. Look at here. For my convenience, I will take. Right. Second ray. Now, third ray of light incident at pole, again reflected back. How this is? Look at me. Again, I will take this nothing but one ray of light. This ray of light incident at at pole. After incident, consider this ray of light reflected back. How it reflected back? It can reflected back like this way. What we got? After reflection, all the ray of light meeting at this point. This point, what I can call this point is nothing but A dash. Right? At this point image appeared. How to take the image now? So if we take this line, this I can call image. So what I can call image? A dash, B dash is nothing but image. A dash, B dash is nothing but image. What is object? If AB represent object, A dash, B dash represent image. How the image can appear now? Now image can appear in front of the mirror and it is inverted. How this image is there? This image actually it is produced in downward direction. So downward mean it is real and inverted. Image is a real and inverted. Now let us use sine conventions. What we know that? Along direction of incident ray, all distance are taken to be positive. Opposite to direction of incident ray, all distance are taken to be negative. We know that distance between pole and object is called as object distance. So shall I take this one? Distance between pole and object, you can call this is the object distance. Are you following this? Distance between pole and image, distance between pole and image, this we are calling image distance, represent by what value? V. Are you getting my point? Now distance between pole and principal focus, what you are calling this? This is focal length. Distance between pole and center of curvature is called as radius of curvature. Are you following this one? Now let us use sign conventions. Along direction of incident ray, all distance are taken to be positive. Opposite to direction of incident ray, all distance are taken to be negative. How the ray of light is coming? Ray of light must becomes like this. In this direction ray of light is coming. Shall I show here how the ray of light can come? Look at me. In this direction ray of light is coming. In this direction ray of light is coming. Right around. So this is the ray of light coming. One more ray of light, how it is coming? It is coming like this and retraces its path. Let us take this point. Shall I take it as n point? Now, all distance must be measured from pole. Then let us use sign conventions. How to use sign convention? The distance between pole and object, that is PB. Distance between pole and object, I taken as object distance and taken to be negative. Because of what? Distance between pole and object. Now distance between pole and image, I mean I can take this value as PB dash is equal to minus V, because opposite to direction of incident ray, all distance are taken to be negative. Now distance between pole and center of curvature PC is equal to minus R, radius of curvature. Distance between pole and principal focus PF is equal to how much? Focal length. Again it is taken to be negative. PF is taken to be negative. PF is equal to minus F. These are sign conventions. Now let us take what is relation between object distance, image distance and focal length. That we'll see. Look at in the diagram. In the diagram, two triangles are there. A, B, C looks like one triangle. Fine. A dash, B dash, C looks like another triangle. Both triangles are similar. Which are triangle? Look at in the figure. A, B, C looks like one triangle. Right. A dash, B dash, C looks like another triangle. Look at here. Two triangles are there. Which are triangle? Triangle ABC. Triangle ABC and triangle A dash B dash C. A dash B dash C are similar. Both are similar triangle. Right. A, B, C, A dash B dash C. Both looks like similar triangle. For similar triangle, ratio of height to base are equal. What is height of this triangle ABC? So shall I take ratio of mean? I can take it is AB divided by A dash B dash. Ratio of height of two triangles. Both are equal for similar triangle according to geometry. Equal to base. Base of this triangle is BC. BC divided by B dash C. Right around this. One triangle. See here. For this side must be equal to this side and this side must be equal to this side. I mean ratio of their sides. Now let us call this is equation number 1. I can call this is equation number 1. Right. Now one more triangle looks like ABP looks like one triangle. A dash B dash P looks like another triangle. Right. Shall I choose here? Triangle ABP looks like one triangle and A dash B dash P looks like another triangle. ABP looks like one triangle. A dash B dash P looks like another triangle. Again these two triangles are similar. These two triangles are similar, right? Again you will take ratio of height to base. ABP, height is nothing but AB. So I can take AB divided by A dash B dash, ratio of height of two triangles. Base of this how much? PC, PB divided by PB dash. PB whole divided by PB dash. Right around this. Both are similar triangle. Ratio of height to base. Ratio of height of two triangles is equal to ratio of base of two triangles. Again we will take this is equation number 2. Right thing. Now just compare equation 1 and 2. You will get the relation. What you will get directly here? See here. Compare equation 1 and 2. 1 and 2 mean BC divided by B dash C equal to PB divided by PB dash. PB dash. Let us call equation number 3. BC. See here, look at in the figure. In the figure, this is BC. I need BC. BC mean how to take? PB minus PC is equal to what value? BC or CB? See here, BC how to get from the figure? From the figure, PB minus PC. PB minus PC divided by A dash B dash. Sorry, B dash C. What is B dash C? This is B dash C. I need B dash C. I mean PC minus PB dash. PC minus PB dash is equal to what value? B dash C. How to take? PC minus PB dash equal to how much? PB divided by PB dash. Are you following me? See here. Just I took BC and took B dash C from the figure. Now let us solve it. Let us solve it. We will get the conclusion. See here, we know that PB according to sine convention. According to sine convention, PB is equal to minus U. PB is equal to minus U. Minus of PC. PC is equal to minus R. Minus into minus, that becomes plus. Divided by. Right. PC. PC is equal to minus R. PC is equal to minus R. PB dash. What is PB dash? Is equal to minus V. Minus into minus, that becomes plus. That is V equal to PB. PB is equal to minus U. PB dash is equal to minus V. Are you following this? Again I will solve this. Minus U plus R whole divided by minus R plus V is equal to U divided by V. Right? Now let us make it cross multiplication. Cross multiplication means just I will take minus U into V plus what value? V into R is equal to minus U into R plus U into V. Right? Got my point? Now simply I will divide whole this equation by UVR. UVR. How to take? If I divide here UVR. Again I will divide here UVR. Again I will divide UVR. And similarly here also. UV divided by R. Right around this. What values get cancelled? U get cancelled, V get cancelled. What is remaining? Minus 1 by R remaining plus R get cancelled, V get cancelled. What is remaining? 1 by U remaining equal to U get cancelled, R get cancelled. What is remaining? Minus 1 by V remaining plus U get cancelled, R get cancelled. What is remaining? 1 by R remaining. Just I want to exchange the values. So this minus R bring this side, minus V bring this side. What we will get directly? 1 by U plus 1 by V is equal to 1 by R plus how much? 1 by R. Following me this. Then again 1 by u plus 1 by v is equal to LCM is R. 1 plus 1 is equal to 2. Write out this. Remember this. I can call simply this is equation number 4. I can call. Right. Then we know this relation. What we got relation between focal length and radius of f is equal to r by 2. F is equal to r by 2. Or 2 by r is equal to how much? Make it reverse. 2 by r. 2 divided by r is equal to how much? That is 1 by s. Right. 2 by r is equal to 1 by f. 2 divided by r. F is equal to r by 2. F is equal to r by 2 or 1f is equal to 2 by r value. Then put here 2 by r is equal to 1 by f. What you got? What you got here? 1 by u plus 1 by v is equal to how much? 1 by f. This is what? Relation between object distance, image distance and focal length. See here, what you got directly? We got the mirror formula in this way. 1 divided by u, look at me here, may not be appear. 1 by u plus 1 by v is equal to 1 divided by f. This I can call mirror formula. What I can call mirror? I mean relation between object distance, image distance and focal length, this we are calling mirror formula. When real image appeared, when object is placed behind center of curvature, then real and inverted image appeared. Real and inverted image appeared. But this mirror formula can apply always for real image, either for virtual image. Either by taking concave mirror you can obtain, or you can take convex mirror you can obtain this mirror formula. But here for our syllabus we have the concave mirror. For concave mirror this is nothing but what? Mirror formula. Relation between object distance, image distance and focal length. But for this concave mirror here real image appeared. When it is appeared, real and inverted image appeared whenever object is placed behind the center of curvature. Behind the center of curvature. But and how the image appeared? Image appeared between principal focus and center of curvature. Between principal focus and center of curvature image appeared at this point. Right around this. Now, when virtual image appeared for concave mirror. For concave mirror, virtual image appeared wherever object is placed between pole and principal focus. Look at here. How it is? Shall I draw here? Here only I can draw. Simply I will take this nothing but what? Concave mirror I will take. Look at me. For simple convenience I will take. This is concave mirror. How virtual image appeared? Because this is real. Image appeared in front of mirror. This we are calling real. Real and inverted image. Look at me here. I can call this is nothing but what? Principal focus. I can call this is focus. Now consider at this point focus available. Object placed between pole and principal focus. How the object is placed? Look at me here. Let us consider this is nothing but object. Object placed. Let us take this is nothing but size of the object. I can call this is AB. Now let us consider the ray of light incident. Ray of light incident. How it is? Look at me. One more ray of light incident from this object. After incident, ray of light must be reflected back and it is passing through principal focus. Right? Now let us take one more ray of light. See here how it is. Let us take one more ray of light is passing from this point. Shall I take? One more ray of light is passing like this incident at this point, again reflected back. Right? One more ray of light is passing like this. I mean all ray of light is reflected back. This is reflected ray, this is reflected ray. Then how to produce the image? If the case this reflected ray produced in backward side and this reflected ray produced in backward side, all reflected ray meet at some other point, say A dash. Then if we take A dash and B dash, that represent image. How it is? This reflected ray if we produce in backward side and this reflected ray produced in backward side. Look at me. Once again I will take. Look at me. How it is? See here. Shall I take? Look at me. This is nothing but concave mirror I will take. This is principal focus of. This is principal axis. I can call this is pole. Now let us consider object is here. This is the object. Let us take this object is equal to AB. And ray of light incident get reflected. How it get reflected? it get reflected through what? Principal focus. I can call this is focus point, right? Again one more ray applied. Let us take one more ray applied is passing incident at this point, again reflected back. How it is reflected back? Now this ray applied may be reflected back through center of curvature, like this. Let us call this center of curvature. This is reflected ray, this is reflected ray. If all reflected ray position backward side, they can meet at some other point. At this point they can meet. So this is principal axis, right? This is pole. If we take this point, A dash, B dash, A dash, B dash, that represent image. Object is available here, image is appear here. So that how it is? Image appeared behind the mirror. This we are calling virtual image. This we are calling virtual image, and what we are calling this real image. This mirror formula either can apply for real image and for virtual image. Either apply for concave mirror and for convex mirror. The further study regarding this, we'll see in the next session. Thank you guys.